this video is covering section 11A, which is simplifying rational expressions. When you hear the word rational, that's a new word. Think fractional. We have expressions, that's looking at algebraic expressions with variables as fractions. Okay, so we're going to do just kind of a brief review of how to reduce fractions. So when we reduce fractions, we're looking for common factors. We're looking for the greatest common factor in both the numerator and the denominator. So when we look at 24 and 60, the greatest common factor of 24 and 60 is 12. So then 24 breaks down into 12 times 2, and 60 breaks down into 12 times 5. And then what happens is the 12 divided by that 12, anything divided by itself is just 1. And so then we're just left with the 2 over 5. Okay, so you've done that before. Then we have when we introduce variables. We did this in the unit a couple of units ago. So 15y over 25y to the fourth. I'm going to, for this first problem, just break this down. So 15 and 25 have 5 in common. So we would write 15 times 3 times y for our numerator. And in our denominator, we have 5 times 5. And then y to the fourth means y times y times y times y. Then what's going to happen is you can cancel the 5 and the 5 here will become 1. And the y will become 1. So then what you're left over with is a 3 in the numerator. And in the denominator, you have a 5 and y times y, which is y cubed. Okay, so just kind of a review on simplifying fractions. Now, before we kind of talk about rational expressions, we want to kind of get to review in factoring, because what we were doing in those first two examples is we were factoring both the numerator and denominator and canceling out those common factors. So to simplify a fraction with polynomials, remember a polynomial is an expression with x's, like x squared plus 2x plus 3. So you want to factor the numerator completely, then factor the denominator completely, and then you want to cancel any factors that are common to both. Okay, so before we do that, we're going to just get some practice factoring. We've done this before, just kind of a review. So for part A, is there anything that can factor out of 2x and 3? No, 2x and 3 have nothing in common, so this is what's called prime. Okay, so its only factors are 1 in itself. For part B, we have factors of 3x and 6. The common factor is 3. So when we factor out of 3, we get x plus 2. So 3x plus 6 would break down into the factors of 3 and x plus 2. For part C, we can take out an x, so then we have x plus 1. So those are those factors. Now, x squared plus x plus 1 in part D. This is a trinomial. So to factor a trinomial, we have to use the AC method. So a times c here would be 1, and then the only factors of 1 are 1 and 1. Now, the only thing that 1 and 1 can make, when they subtract, they make 0. When they add, they make 2. But for this problem, I want them to add or subtract to make 1, which is not possible. So this cannot factor, therefore we call this prime. Okay, now we could use the quadratic formula for that one, but quadratic formula doesn't find factors. So this could not factor, so that's prime. Now for part E, we can do the AC method. A times C is 1 times negative 2, so that's negative 2. The only factors of 2 are 1 and 2, and I want to make a negative 1 out of that, so that means the 2 would have to be negative, because 1 minus 2 is negative 1. Now, this is the shortcut with AC method because A is 1, so now we can go directly into x plus 1 times x minus 2. Now, we're not setting this equal to 0, so we're not finding what x equals, that we're just factoring, so that's our answer. All right, and then x squared minus 9, I hope you recognize that as a difference of squares. So x is squared, and for 9, the square root of 9 is 3. That's a perfect square. So remember, a difference of squares can break down into x plus the square root of 9 is 3, and x minus 3. Okay, so that's the factors of x squared minus 9. Okay, so a little practice because we're going to be doing that in what we're learning for this lesson. All right, so what we're actually doing today is, like I said, simplifying rational expressions. They're going to look more like what you see in example 4. But before we get to example 4, there's something that I want to make sure. This is a big mistake that a lot of people make. So I want to make sure you do not ever, ever, ever make this mistake. So in example set 2, it says describe the error. There is a mistake in what you see here in the following. So we have 3 plus 12 divided by 3 plus 15. Now what this person did is they canceled out the 3's, leaving us with 12 over 15, which is 4/5. This is absolute. I want you to put this on your notes. This is absolutely incorrect. You never, ever, ever should do this. Okay? So the reason you cannot do that is because the 3's are being added to 12 and 15. If this was 3 times 12 and 3 times 15, then you could do this. You could cancel out the 3's. But since they're adding, you absolutely cannot do that. All right, so how can you do that? So let's do that. You can never cancel when adding terms in the numerator or denominator. Okay, only when multiplying. All right, you can only cancel common factors if you're multiplying. Never, ever, ever when you're adding or subtracting them. Okay, so for example 3, it says, how could the work above be corrected without actually finding the sums 3 plus 12 and 3 plus 15? What they mean is, instead of just adding 3 plus 12 is 15, 3 plus 15 is 18, and dividing, how else can you do this? I want to show how you could actually do this in a little bit different way. All right, so what you could do is, you see how 12 and 15 both have factors of 3? So I'm going to break 12 and 15 down into its factors of 3. So 12 is 3 times 4, and then 15 is 3 times 5. Now, you can only cancel if every single term, so what I mean by terms are separated by pluses and minuses. If every single term in the numerator and the denominator, all of them, have a common factor, then you can cancel things out. But it's still a little tricky here. Okay, so the 3's, you can divide every single term by 3, but what's going to happen is when you divide by 3, each 3 becomes 1. So like 3 divided by 3, that becomes 1. 3 divided by 3, that becomes 1. This becomes 1, and this becomes 1. Okay, so what you're actually going to get is the 3's, these first 3's here, they don't cancel out completely. All right, they become 1 plus 1 times 4 over 1 plus 1 times 5. You see all my 3's canceled, but when they cancel, they don't go away. We're left with a 1. All right, so then we have 1 plus 4 is 5, and 1 plus 5 is 6. Okay, you'll see kind of that later and how that will affect our later examples. Okay, all right, so now, example 4. Now we're just going to get practice with simplifying each expression. So go back to the first page. To simplify a fraction with polynomials, we have to do 3 steps. Factor the numerator completely, factor the denominator completely, and then cancel out common factors. So for example A, 6 can be factored into 2 times 3. So you can do that. I'm not necessarily going to do that for this one. Because sometimes you might not have a common factor in the bottom. So I'm going to leave 6 alone, but then I'm going to factor the denominator, 2 times x plus 3. Okay, so 2x plus 6 can factor into 2 times x plus 3. Now, if you look, 6, remember, was 2 times 3, so 6 over 2 can reduce. And when I reduce that, what I like to do is I cross those out, and 6 over 2 becomes 3, so I'm going to put a 3 up now in the numerator. So now this answer becomes 3 over x plus 3. So we simplified, it's like reducing that fraction. Okay? Now for part B, the numerator can factor into m times m minus 5. The denominator is just still m squared. But remember that m squared is like m times m. So if you wanted to write that as like m times m, you could. And then you have an m in the numerator and an m in the denominator. So those cancel out, making 1. So my final answer is m minus 5 over m. Okay? All right, my next problem, 5c minus 15. The common factor is 5, so when I factor that out, you're left with c minus 15 divided by 5 is 3. In the denominator, we have 3c minus 9. The common factor is 3, so then we get c minus 3. So now we have the entire c minus 3 over c minus 3. So these factors are going to cancel out, also making 1. So then our final answer is 5/3. Okay. All right, part D. In part D, we have the numerator, 5y squared minus 15y. The common factor there is 5 and y. So when you take out a 5y divided by 5y squared, you're left with y minus 15y divided by 5y, you're left with a 3, but no more y. In the denominator, we have 10y cubed plus 60y squared. 10 and 60, their GCF is 10. And then y cubed and y squared, the GCF is y squared. So when I take out a 10y squared, you're left with y plus 6. Okay, now this one at first glance might not look like it has common factors, but it does. 5 over 10, that can reduce. And it does not reduce to 2, it reduces to 1/2. So 5 over 10 does reduce, but the 2 is going to be in the denominator. Okay? Also, you have a y times a y squared. Now, the way you can do this is I have y in the numerator and y times y in the denominator. So you'll have a y in the numerator cancel. You'll also have a y in the denominator cancel. I kind of do that by canceling this out and saying that's going to become 1y, y to the first power. Okay, now if that's confusing to you, you could kind of do this another way by breaking the bottom denominator down a little bit further. So you can break 10 down into 5 times 2, and you can break y down into y times y. So if what I wrote in green was confusing, then break everything down completely. And now you see you have a 5 and a 5 cancel, a y and a y cancel, and that's all you can cancel. So then you'll be left with y minus 3 in the numerator divided by 2y times y plus 6 in the denominator. Okay, so there's some like shortcut ways that you can get around, but if those shortcuts are kind of confusing for you, then you're going to have to break everything down. Okay? All right, so now for part E, we have 5a plus 35 in the numerator. So to factor that, we have 5 times a plus 7. And then the denominator, a squared minus 49, that's a difference of squares. So we have a minus 7 times a plus 7. And now we can see that a plus 7 and a plus 7 cancel, leaving us with 5 over a minus 7. All right, last example for F, we have a trinomial over a trinomial. So we have to factor both of these using the AC method. So for the numerator, we have negative 5 is a times c. The only factors of 5 are 1 and 5. But to get positive 4, we would have to subtract 1. So the numerator becomes x minus 1 times x plus 5. Then the denominator, we have to use the AC method. A times c is negative 3. And so only factors of negative 3 are 1 and 3. And to get positive 2, we have to subtract 1. So the denominator will be x minus 1 times x plus 3. Then you see that the x minus 1s will cancel, leaving us with x plus 5 over x plus 3. Now remember that when you get something like this, you cannot cancel the x's in this because we're adding instead of multiplying. So this is completely simplified. Okay, for our last bit of notes, it's important that you know a couple of things here. So changing the order of addition and subtraction. When you change the order of addition, so if I have A plus B and B plus A, they're actually the same. Okay, so if I have 2 plus 3, that's the same as 3 plus 2. They're both positive 5. However, if you subtract and you switch the order, 3 minus 2 is 1, but 2 minus 3 is negative 1. So subtraction, you cannot just switch the sign. They're not the same. They'll actually end up being the same value, but they're going to be the opposite sign. Okay? So addition, switching them are the same. Subtraction, switching A and B, they're going to be the opposite sign. Okay, so how to show that? So if I take A minus B, and if I switch those, then to switch those to be the same, negative B would still have to be negative. So like A minus B is equal to negative B plus A. Now, if I make both of those negative, so I'm going to put a minus in front of both of those. Okay, so I just put a negative with the parentheses in front of both, so they're still the same. And then I'm going to factor that negative, or distribute that negative for the second one. So negative times negative is positive B, then minus A. And so you can see that when you switch the signs, A minus B to B minus A, you see they're opposite signs. So I was just kind of proving how that worked to you. Okay? All right, now how this works when we simplify rational expressions is sometimes you'll get factors where the A and the B are switched. Okay, so let me show you what I mean by that. So in part A, if we factor this, the numerator has a 3 in common. So we get 3 times x plus 2. The denominator, the 5, is in common. So then we have 2 plus x. All right, and so you can see that in the numerator I have x plus 2, in the denominator I have 2 plus x. But we just learned that if we switch with addition, those are actually the same. And so if they're the same, then they're just going to cancel out to be 1, and we have left over 3 over 5. Okay? So when we get to B, when I factor, you have 4 in common in the numerator, so you get A minus 1. And in the denominator, you have 7. So now that's going to be 1 minus A. Now this one's a little different than the first one, in that A minus 1 and 1 minus A, they're not the same, but they're opposites of each other. Okay, so they're still going to be the same number, just opposite sign. So the way that I do this, these will cancel to be 1, but it's going to be a negative 1. Okay, so whereas the one in part A, I could cancel this out with one line and show that those are going to go to 1. Those are going to become 1. So 1 times 3/5 is just 3/5. But in part B, these, when they cancel out, are going to become negative 1. So I get 4 over 7, but times negative 1. So when the opposites cancel, you have to make your answer negative, or the opposite sign. Okay? So for part C, let's try again. 2c minus c squared. There's a c in common, so we factor out a c, leaving with 2 minus c. In the denominator, we have c cubed minus 2c squared. C squared is in common, and then you're left with c minus 2. Again, 2 minus c and c minus 2 are opposites, so when we cancel those out, I want you to show that becomes a negative 1. Also, in the denominator, you have c squared, which is like c times c. So one c in the numerator is going to cancel, and one c in the denominator is going to cancel. So actually, in the numerator, you have nothing left except negative 1. In the denominator, you have a single c left over. All right, we're almost done. A few more examples. So in part D, 6m minus m squared, and m is in common, so we factor out the m, leaving us with 6 minus m. In the denominator, m squared minus 36 is a difference of squares, so that becomes m plus 6 times m minus 6. Now again, notice 6 minus m and m minus 6 are opposites, so when those cross out, they become negative 1. So that negative will multiply with the m to make negative 1m over n plus 6. Okay? All right, for part E, in the numerator, we have a squared minus ab, so a is in common, leaving us with a minus b. In the denominator, that's actually a difference of squares, b squared minus a squared. So when I do that, you have b minus a times b plus a. Now notice again that a minus b and b minus a, those are opposites. So when they cancel out, we're left with negative 1. Negative 1 times a is negative a over b plus a. Final question, almost done. In F, we have 6 minus 3x. The common factor is 3. When I factor that out, you get 2 minus x. In the denominator, that's a trinomial, so we factor with the AC method. So the a times c is negative 2. Factors of 2 are 1 and 2. To make negative 1, that means the 2 has to be negative. So my denominator is x plus 1 times x minus 2. And notice we have, again, opposites. So when we have opposites, when those cancel, they make negative 1. So negative 1 times 3 is negative 3 divided by x plus 1. Okay? And that is simplifying rational expressions.